Hi everyone, and welcome to a little video about flowcharts. Now this flowchart video is going to help you with the enrolment assignment, and we're going to be looking at a few different ideas including logical thinking and then how we can represent flowcharts, algorithms using a flowchart. Okay, so let's break those down to start with. We are going to be looking at various different ideas as we progress through here, and two of the key ones are abstraction, which is where we remove any unnecessary details and we simplify a procedure so that we can really focus on what's important. That then allows us to make sure that whatever we're creating is as efficient as possible. We've then got the idea of visualization, and that's where we present information that makes it easy for humans to understand, and it allows us to really explain complex ideas or complex situations in a much more simple way. Now what we're going to be representing are this idea of an algorithm. Now an algorithm in its most basic form is a set of instructions to solve a problem in a finite number of steps. So they are basically our code. Okay, so these are going to represent our little computer programs, if you like. Now in order for us to understand the flowcharts, we have to understand the individual symbols. So I'm not sure if you've met these before, but first up we've got a terminator symbol, and that's just a start or a stop, and it signifies that we're either going to begin an algorithm or we're going to stop an algorithm. Next up we've got process or calculation, and as the name suggests, this is where we do any calculations, any mathematical addition, subtraction, multiplication, etc., or where we update what are called variables, which are little bits of data where we can store either numbers or text or things like that. Okay. Next up we've got inputs and outputs, and that's where we either get information from our user or we present the result of some calculation back to our user. Next up we have a logical decision, and that's where we carry out checks such as branches or iterative loops, and we basically ask a question. So is x greater than y, for example, and if it is, we could go down one path, and if it's not, we could go down a different path. Our penultimate symbol is what we call a predefined process, sometimes called a function, sometimes called a subroutine, and that is where we represent a more complicated series of steps in a much more simple way using this idea of abstraction. Okay, and I'll show you an example where that's been employed. Finally, we've got how we connect all our symbols together. Typically we use arrows, but sometimes lines are used too. As long as we can make our way through the logic, then it's absolutely fine. I don't mind which ones you use. So let's start with a really basic flowchart, and this allows us to demonstrate a programming construct. So a programming construct is a really basic building block, and we're going to look at something called sequential programming, or a sequence. So in order for us to understand that, we have to, I've mentioned this word already, but understand a variable. Now, as I've put on the left hand side of the screen, we've got a box, and inside that box we can give it a name and we can store whatever we like. So as I've already mentioned, it could be text, or you could input a number in there. And as long as we follow the naming conventions, so that's if we have a multi-part name, they are separated by underscores, we can call a variable whatever we like. So I've got several here, I've got 3 in fact. So if we start at the beginning, we then input height. So height would be one of these boxes, would be a location in memory in fact, and we would store whatever the user types in for a height. We would then do exactly the same again and input a width. So we'd have a box called height, a box called width. We'd then create a third box or a third variable called area, and whatever's in height we would multiply by whatever's in width and then output that back to our user. Okay, so again, this is very simple programming. We call this a sequence. Okay, next up we've got this idea of branching. Now branching sometimes goes by the name of selection as well, where we select a particular path, but we're going to call it branching for today. And that's where we take our data and we perform a check, or we make a decision based upon the result of some calculation, and then we end up with multiple possible outcomes. Now in the flowchart to the left here we've got 2 possible outcomes, but there could be lots more if you so wish. Okay, so our little program here, as you can see, is used to work out which of two numbers is the greatest. So if we input x and then we input y, we can do that in one box if we like, and it'll save a little bit of space rather than doing it as I did on the previous slide where we had height and width as separate input boxes. But it's absolutely fine to do what I've just done here and input x and input y all in one space. We then perform our check, so this is where our branching would occur, and this is where we are testing our logical decision. We are asking, is x greater than y? If it is, we would then follow the left branch where it says yes and output x, otherwise we would follow no and output y, and then we would stop. Again, the idea behind branching is that you can test lots of different possible outcomes. Our third programming construct is called iteration. And this is where we have the same kind of decision or check, but we could run it once, we could actually run it 0 times, or we could keep running this in theory forever. So this little algorithm finds the external angle of a particular shape. Okay, so we input number of sides, and this is just a variable to check how many sides the shape is that the user wants to check. So we input number of sides. If they've entered, for example, 2, then number of sides will not be greater than or equal to 3, so we'll ask them to input it again. And if they put 2 again, they could keep going around this loop or keep going around the check infinity times. Hopefully they'll eventually put something that's acceptable. So let's pretend that we put in 4. 4 is greater than 3, so we then progress to work out the external angle of a side with 4 shapes, and we'd work out that as 360 divided by 4 and give us 90 degrees. Okay, that would be then output to our user. Now, based upon those 3 programming constructs, you should now be able to follow this through and have a go at this previous exam question where on your worksheet you can input where we've got a hexagonal shape, a parallelogram or a rhombic shape. Okay, if you follow the bullet points you should be able to work that out. So have a go now and then come back in a second. The assessment that goes in hand with this particular video and this little exercise is mostly focused upon using trace tables. Okay, so to start with, I'm going to look at the idea of a factorial. Now, the factorial of a number is when we take a whole number, an integer, and we say whatever that number is, we're going to keep timesing it by that number minus 1 until we get to 1. Now, it sounds really quite complicated, but it's not. So if I took what the factorial of 4 is, then I would do 4 times by 3 times by 2 times by 1. Okay, so 4 times 3 is 12, times by 2 is 24, times by 1 is still 24. Okay, so you can work that out. Now, in this particular algorithm, I've hard-coded what 5 factorial is, and what we want to be able to do is trace through that using a trace table. Now, a trace table should always have on it any inputs. Now, there aren't any inputs on this particular diagram, on this particular flowchart, but we do have 2 variables. We've got number, which is initialized to 5, and then we've got factorial, which is initialized to whatever number has in it, which happens to be 5 as well. And then we've got an output, so we always denote whenever we output to our user. Okay, so if we trace through this, as I've said, we've assigned 5 to number and we've assigned 5 to factorial. We would then check if 5 is greater than 2. Well, it is. So we go across to the left and we say that number becomes equal to number minus 1. And as you can see from the next line of my trace table, that equals 4. We then update factorial to be whatever factorial was, which is 5, and times it by this new number, which is 4, and that gives us a new value for factorial, which is 20. Now, I'll let you trace through this mentally. We would check to see if 4 is greater than 2. That would then still be true. So we'd update our new values. Hopefully you've got the idea now. So we would get number equals number minus 1, which is 3, and we get factorial becomes equal to 20 times by 3, so we would get 60. Again, we follow that round, and is number still greater than 2? Well, yes it is, so we repeat the process. So number would go down to 2, factorial would then be updated to 60 multiplied by 2, which is 120. And then it's at this point where our check would change its state. So 2 is not greater than 2, so that becomes false. So we would output whatever is in our factorial variable. So our output would be 120, and then our algorithm would stop. Okay, so I want you to have a practice of using these trace tables now, because again, this is going to be in the little mini assessment. This particular flowchart sets two variables, I equal to 0 and j equal to 10. And what the check is while I is still less than j, update I to be I plus 1, and then update j to be j minus 1, and keep performing that check. And I'd like you to try and work out what the final I and j values are. If you need to add more rows, please feel free to, or if you just want to continue to write on your worksheet in the boxes provided, I've hopefully put in enough, but if not, you feel free to add some more. And then this idea of abstraction, bringing it back to our first slide. We talked about the fact that you can represent ideas in a much more simple form. And this little flow chart takes the same idea of inputting a number of sides and then checking if we've got an answer greater than or equal to 3. Then it checks to see if the user has inputted 3, 4 or 5. Okay. If they've inputted 3, we'd go to the predefined function called calc area of a trie. If they've got 4, calc area rect, and if they've got 5, calc area pent. Okay, for a pentagon. And these little blocks of code would make our program a lot more complicated. So what we do is represent them using the subroutine icon, and then we can draw our subroutine elsewhere on the page, which makes it much easier for a user to follow. This little algorithm here is much easier to work out than if we had everything all in one massive flowchart. Okay, so this idea of breaking it down using abstraction makes our idea much more simple. So I'll take one of these as an example. So if I break down calc area rect, I would then do the next steps, which is to break that down. So calc area rect, I would use a terminator symbol still, but I would match whatever I've called my subroutine. So we've got calc area rect to denote that that's where we're starting. We'd then input two variables, side 1 and side 2. We'd then do area equals side 1 times side 2. And then this idea of returning a value, I can send whatever's inside area back to my original programming, and then I can output that. Okay, so obviously if we had two numbers and we had 2 and 3, we'd then multiply those together to get 6. We would then send 6 back to our main program and output that area at the end. Okay, so just as a little exercise, what I would like you to do on your worksheet is to work out the subroutine for calc area of a trie and then calc area of a pent. Okay, what we are then going to do, it's your last little challenge, is to put this all together. Feel free to use these subroutines to simplify your program and then separate them out so you don't have to do one giant flowchart. If you do want to do one giant flowchart, that's absolutely fine, but it might make it a little bit more simple to follow if you do break this down. And what we're going to make a flowchart of is a little guess the number game. You're going to give a user 3 lives, and then you're going to generate a random number between 1 and 10. What you're going to then do is check to see how many lives they've got. If it's still greater than 0, you're going to allow them to input a number. At that point, you're going to check the number they've inputted against the random one you've created. And then if that number is greater than the number, you're going to tell them that they are too high. If their number's less than that number, you're going to tell them that its output is too low. And if their number is exactly what they want, you're going to say well done and give them a pat on the back. Okay. Obviously, as I've said on step 3, the number of lives is going to need updating. So if they get either too high or too low, they're going to need to update how many lives they've got, so take 1 away. If they then lose all 3 lives, please tell them what the number was before finishing, so they're not left in limbo. Obviously, they'll be really gutted if they don't find out what that number was. And then obviously stop the algorithm. Okay, so hopefully the process is, or the idea of the game is not too difficult, but what I'd like to do is put all these ideas together to create a flowchart that would represent this. Our very final step is to create 2 trace tables like we've done before of any inputs, of any variables, and of any outputs, each represented as a column, and then show both possible outcomes, one where they guess the number and how that works, and then one where they get it wrong 3 times and how that would work. Okay, so we've got our different permutations, if you like, so that we can check that your code would actually work. Now, all of this is on the enrolment assignment, and hopefully you've got a copy of this already. If not, you can email me or you can ask for this and I'll email it to you. Okay, so thanks very much for making it this far through the video. Remember, in September, all I'm assessing is your ability to think logically. You won't have done GCSE computer science before, and that's why this project, this idea is really quite small. But what I'm going to be looking at is your ability to problem solve. I want you to show me your process, to show your thinking, to show how your thinking evolves over time. So please, please, please have fun with this and don't be afraid to make mistakes. Don't present me just with a final answer if you've had to go through 3 or 4 flowcharts to get there. What I'm interested in, what I really want to see, is that you've not been afraid to get things wrong, you've got stuck in, and that you've then evolved your ideas over time. Okay, that in essence is exactly what a programmer has to do, and no one's perfect to start with. Okay, even me. So what I would like you to do is, if you get really stuck, please feel free to contact me, and I will endeavour to get back to you as soon as I can over the summer. So thanks again for your attention, and hopefully all of this makes sense. If not, like I said, please get in touch.